Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Hey, my name's Philip. I'm going to Princeton University next year for mechanical engineering. I got a 5 on both sections of the AP Physics C test, and I'm going to help you learn high school physics. Hopefully. So right now you might be thinking to yourself, oh my god, I'm stupid. I can't do physics. You're wrong. With one caveat. You see, if you're not good at algebra, physics is a lot of equations with lots of symbols that you really need to be able to move around. You have to move them around everywhere. Everywhere. So don't take physics if you're not good at algebra, or if you have to take physics, take whatever the easiest physics is. But besides that, you can do physics. First things first, you need to know lingo. Go. So the first thing that's a little bit weird that you're going to find out about physics is that there are things called magnitudes and vectors. You're probably familiar with magnitudes. I have a gallon of water. That's a magnitude. Or 1 foot. If I were to say that this is a 4-finger poke, that's a magnitude. It becomes a vector when I add a direction. So 4-finger poke that way. I don't know why I slapped myself like 5 times. So the first thing we're going to talk about is kinematics, which is for objects that have a constant acceleration. Position. I think you probably understand that. That's where you are. Here, in a position. The next thing you need to know is things about changes in position. You're probably familiar with distance. You run a mile. That's a distance. But in physics, we use displacement, which is different than distance because it's only your final position versus your initial position. Okay, let me explain. I can do all this. What's it to do to die today as a minute or two to two? A thing distinctly hard to say, but harder still to do. At a minute or two till 2. And I moved around a lot. I've covered a good deal of distance, but ultimately my displacement was 0 because I ended up right back here. Also, you know speed. It's a measure of how fast you're changing your distance, you know. Running speed. 3 miles an hour. It's a 20-minute mile. Pretty easy walk. Velocity is different. It's speed with a direction. It's a vector. For instance, if your displacement is in meters, then your velocity would be in meters per second. Finally, you have acceleration, which is your change in velocity over time, or meters per second per second. Yeah, I know it sounds confusing, but essentially you know what it is. The faster you're speeding up, the faster your acceleration is. One more thing. Acceleration is a vector, like everything else that we've been talking about. So it matters what direction it's in. If your velocity is that way, but your acceleration is going the other direction, you're still changing your velocity at that rate, but you're changing it so that it comes closer to going this direction. It's all about direction. You really should draw these things out if you're doing a problem. It helps a lot. Draw things. Draw things. Draw things. So, equations are your friends. I have 4 of them to show you right now.
This equation describes an object's position when it has a constant velocity. You might have seen it in algebra as distance is equal to rate times time. Basically, it applies when you have a constant velocity and the object's position is changing over time. It's pretty much the simplest equation. This equation describes the change in velocity over time with an object that has a constant acceleration. It looks a lot like the one before it, which makes sense because as velocity is to position, acceleration is to velocity. This equation is the longest but also the most comprehensive. It includes position, initial velocity, and acceleration and time. Basically, It's the first equation, but adding in acceleration over time. You derive it from calculus, but that's not really an issue for you if you're taking first-year physics. It's a very good one to know because it can apply in almost any kinematic situation. Finally, we have this equation, which is one of the most forgotten ones, but also one of the most useful. It relates velocity, acceleration, and position without time. So when you have something and you don't need to know the time or you can't know the time, this is actually an easier way to solve it. If you haven't written all these down, now would be a very good time to do so. I would suggest memorizing them before your first test, even if you're going to have an equation sheet available. It always helps to have it memorized. You work much faster.
Now I've got a set of 3 problems for you. 3, well, slightly more interesting problems, because everything in physics is like a ball's rolling down a hill, how fast does it roll? Things falling through the air, whatever. These are better, I hope. And hopefully a little bit more relevant to you, if you're a nerd. Or not a nerd.
If the sun grows at a rate of 0.000000096 astronomical units a year, how many years is it until it swallows the Earth, which is 1 astronomical unit away? If a football player is running at 3 meters per second to the right, and it takes another football player 2 seconds to tackle him, what was the magnitude and direction of the acceleration? If Captain Kirk falls 6,000 meters from his ship to a space station at an acceleration due to gravity of 9.8 meters per second, how fast is he going when he lands? Hint, there is a right way and a wrong way to work this question. Second question, how long did it take him to fall? Second hint, if you already know the answer from working the first part, you did it the long way.
The reason I said there was a right way and a wrong way on that last problem is because in physics there's often multiple ways you can solve a problem, but usually one is much, much easier than the other one. For instance, in this one, if you used v squared is equal to v naught squared plus 2a delta x, you only had to use that one equation. But if you went through the very long x is equal to x naught plus v naught t plus 1/2 at squared, you had to find time and then plug that into another equation to find velocity, which, let's agree, that's a lot of extra work. And it gets worse the farther into physics you get, so always try to look at a problem and do it the simplest way. Well, that's the first lesson. My name's Philip. Bill Nye, the science guy.
Bill Nye, the science guy. Bill